Next, we will discuss how to integrate a variety of functions that contain an exponential function. First of all, we are going to convert the knowledge of the derivatives of the exponential functions into the knowledge of the indefinite integrals by rewriting the statements in the integral form. Now we can add them to the table of integrals. Let's do an example. We first recognize the pattern and rearrange the integrand. Then set up the substitution by setting a new variable, let's say t, equal to x cubed, and finding the differential of t. Next, we plug everything into the original integral, and notice how, because of the discovered pattern, we have nothing but the function of t left in the integral. We finish the process by finding the antiderivative and plugging the original function x cubed back for it. Let's do another example. We again first recognize the pattern and rearrange the integrand. Then set up the substitution by setting a new variable, let's say t, equal to 1 plus e to the x, and finding the differential of t. Next, we plug everything into the original integral, and notice how, because of the discovered pattern, we have nothing but the function of t left in the integral. We finish the process by finding the antiderivative and plugging the original function e plus e to the power x back for t. Let's do an example of a linear substitution. We set up the substitution by setting t equal to 3x minus 4 and finding the differential of t and expressing dx in terms of dt. As a result, we have a simple indefinite integral in terms of t. We continue with the integration process by finding the antiderivative and replacing t with the original function. We discussed how to integrate a variety of functions that contain an exponential function.